Okay, so I'm going to talk about some examples where we have to find values of trig functions given a point on the terminal side. So let me just go into what the question is. I did this in another video, so these are just more examples. For each given point, sketch the angle of theta in standard position such that theta has the least positive measure and the given point is on the terminal side. Find the values of the 6 trig functions. Okay, so like I said, I did this in another video. This is kind of like orienting ourselves with trig functions. So I'm going to do this example now with these 3 extra examples. So the idea behind this is we've got a point. So what I want to do is I want to have a terminal side going through this point. So remember, you start with your initial position. The initial position always starts here when we're talking standard position. And then we swing over to what would be our terminal side that goes through the given point, okay? And what we're interested in is the right triangle created between the terminal side and the x-axis. And we kind of measure these sides and we use the distance formula to help with this. So I broke all this down in another video of kind of how this works. So I'm just kind of reminding you. So the way that I think about this, then I use the point to help me determine how I'm going to interpret the sides. So this side is -3, this side is 4. So I'm using that point and that this is 0, 0. And I need to reflect the quadrant that it's in. So you don't want to think of this necessarily as like a distance, or if you do, you think of it as like a negative distance. But you have to take the negativeness of the point as part of the side. And then we have to find the hypotenuse. So what I'm going to do then is I just take -3 squared plus 4 squared. So I work this out. I have, this becomes 9 and 16. So I just have the square root of 25. So my r in this case is 5. So I'll just mark that here. And so first you have to figure out kind of the sides of your right triangle. And then you've got your 6 trig functions. And so based on that right triangle, you just write out what this comes out to. Okay. And so this is going to give us like the theta that we've got here, basically. All right. So starting with sine of theta, this is going to be y over r. So I literally just, since I've got this all labeled, this all just comes together quite nicely. So this will be 4 over 5. So this one's going to be 4 over 5. Cosine is x over r. So that's going to be -3 over 5. Tangent is y over x. So that's going to be 4 over -3. So again, I'm just taking these sides, right, and plugging them in. So continuing on, my cosecant of theta, that's r over y. So I have my r over my y, so it's going to be 5 over 4. Secant of theta is r over x. So here's my r, here's my x. It's going to be 5 over -3. And then cotangent x over y. So here's my x, here's my y, so -3 over 4. So that's kind of what you're doing. You're building your right triangle from standard position, and then you're kind of coming up with these relationships given by these trig functions. So you're just getting used to kind of how all these things kind of piece together. Even if it doesn't make sense at first, I think this is one of those things like you do a little bit of repetition, and then as you continue on with like a trig class, this starts to feel more familiar and it starts to kind of all make more sense. So let's do this again. So we're kind of just like repeating this process and getting used to building these. So I've got the 0.74. So I've got, here's 7 and 4, and I've got my terminal side. So the triangle that would be created in this case would look like this. So my x is 7, my y is 4 based off of the point here. And then I just have to find the other side, right? The hypotenuse, the r. So I go through the work to do this. So I have the square root of 7 squared plus 4 squared. So I go through all that. I will get that my r is equal to 65. So I'm just going to note that over here. And then it's the same thing. So I've got the same 6 functions, and it's just kind of plugging in those relationships. So I've got y over r. That's going to come out to 4 over the square root of 65. Now, the thing with this one is, you do have to rationalize these. So I'm going to multiply the top and bottom by the square root of 65. By the way, I've got just a quick video on like how to rationalize in case you forgot. So be sure to check that out. So this is going to come out to 4 times the square root of 65 over 65 now. And then we have x over r. So this is going to be 7 over the square root of 65. Sorry, you might hear my dog crying in the background. Okay, so back to rationalizing. So I multiply the top and bottom now by the square root of 65. So if I do that, I get 7 times the square root of 65 over 65. And then for tangent, so tangent is y over x. So y over x. So that's going to come out to 4 over 7. For cosecant of theta, that's r over y. So that's going to be the square root of 65 over 4. No need to rationalize there. Secant of theta of r over x is going to be square root of 65 over 7. So I'm just taking my r over my x. And then for the cotangent, so I've got x over y. So that's going to come out to 7 over 4. Okay, so that's it for that. So we don't have to simplify anymore with these. So for the last one, this is kind of a wacky looking point. So negative square root of 2 and then the square root of 2, but it's the same process. So I just need to draw a little sketch. So there's kind of where the terminal side's going to end up. So here's the right triangle that I'm interested in. So one side is going to be using, my x coordinate here. I'm going to think of this as negative square root of 2. I'm going to think of this as square root of 2 going in the y direction, and then I figure out my r. So I would highly recommend that you pause the video and just try this one entirely on your own if you are just trying to check your understanding of these. I've done 2 now. I think you kind of get the idea. Pause, see if you get it, and then hit play when you're ready. Okay, so if I continue on with my r, so this comes out to just 2 plus 2. And so I get the square root of 4, so this just equals 2. So that's going to be what my r is. And so now I can just fill in all of my functions. And so then just filling everything in. So for like this first one, so I get the square root of 2 over 2, right? Because that's going to be my y over my r. So that's all I have to do for that one. And then for the next one, that's negative square root of 2 over 2. And then this next one's just a little tricky. Square root of 2 over negative square root of 2. So the square roots of 2's can cancel out. So it's actually just going to simplify to negative 1. And then for the cosecant of theta, so that's going to be r over y. So that comes out to 2 over the square root of 2. And we know that we need to rationalize that. But check out what happens when I rationalize this. So I multiply the top and bottom by the square root of 2. These 2's actually will drop out. So then I'm just left with the square root of 2. And then a similar thing happens with secant theta. So I get 2 over the negative square root of 2. I go through the same work, and so now I get the negative square root of 2. And then for this last one, so now I've got x over y that's going to come out to negative square root of 2 over 2. So that's just going to simplify to negative 1. And so that covers it for these examples. So that's it. Any questions, feel free to leave me a comment or consider liking this video. Otherwise, I'll catch you guys next time.